Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-3 for October-November 2024. And this is part 2 for questions 4 to 6. Question 4 is coming from statistics. On a certain day, the heights of 150 sunflower plants grown by children at a local school are measured, correct to the nearest centimeter. These heights are summarized in the table, and we are given the table here. Okay. Then we are told part A to draw a cumulative frequency. Now we are supposed to draw a cumulative frequency where on the vertical axis we have cumulative frequency, and then on the lower axis we are supposed to have the horizontal axis, we are supposed to have the class boundaries. Okay. But now here we are having distinct intervals. So we have to create a continuity within the values. So the continuity is therefore going to be, we subtract a 0.5 from the lower limit, and then we add a 0.5 in the upper limit. Okay. So what are we going to have? So first let us find the class boundaries. Let me just write here CB and then the cumulative frequencies. Okay. Now subtract 10 minus 0.5, you get 9.5. Then here you add the 0.5, so 19.5. What ends is what starts the next one. So this will be 29.5, then 29.5 to 39.5. 39.5 to 44.5, and then we can have 44.5 here, then to 49.5, 49.5 to 54.5, then 54.5 here to 59.5. Now the cumulative frequencies, of course, we just add the frequencies. So the first frequency is the first cumulative frequency. Then plus 18, you get 28. Plus 32, you get 60. 60 plus 42, that is 102. 102 plus 28, that is 130. 130 plus 14, that is 144. 144 plus 6, that is 150. The last value we get here must be the same as that. Otherwise, whatever we have added is wrong. Okay. All right. Next, we are supposed now to draw our cumulative frequency curve. Let me first reduce this and then I draw. It might be so small for you, but let me first draw the axes. Now we can go back. So you have to put the axes and then you label them. So since my highest cumulative frequency is 150, I can use 1010. Okay, I can use 1010. Let me actually try to enlarge this a bit so that we can see every after 5. So this is 1, 2, 3, 4, 5. So every 5 I can put 10. Then this one here will be 20. So that is what we are having there. And then we can go to the lower axis. Now to avoid doing mistakes here where you have the 0.5s, I'm going to take the 0.5s along these vertical lines. Okay. So I'm going to begin with the 9.5 here. Okay. Then add 10, that is 19.5. Remember, the scale must be uniform, even down here. Don't just write from 9.5 to 19.5, because you see this one here for 40 to 40 for this one, the class width is just a 5. Even here is a 5, and yet these ones are 10. You see? So you have to be careful. The scale has to be the same down here. So this is 29.5. So that is what we are having down here. Now we plot 10 from 9.5. We are plotting cumulative frequencies, okay, against upper class boundaries. So the first one is going to be 19.5 and 10. Okay, 19.5 and 10, which is here. So you plot that point. Then the next one is going to be 29.5 and 28. So first of all, here on this vertical axis, one small box is equivalent to, we are adding 10, 10. So 10 out of 5, which is equivalent to 2. So 29.5 and 28. So it will be one small box before the 30. Then the next one, we are having 60 and 39.5. 39.5 and 60, which is here. Then the next one is going to be 102 with 44.5. 102 with 44.5. Now 44.5 is going to be in the middle here when you add 5. Then you come to 100. It is 102. 102. So 100 is here. Then and 2, one small box just above 100. And then the next one is 130 and 49.5. 130, 49.5. So 49.5 is here and 130 is right up here. Then after that, we go to the last one, I think. 130, there is 144 and 54.5. 54 also has to be in the middle here. So we shall count 5 beyond here. So this is 1, 2, 3, 4, 5. And then 144. So we shall put 2 small boxes above the 140. And then 150 with 59.5. So which is here. 150 is here. So it has to be there. Now we connect these ones to produce a smooth curve. Okay? To produce a smooth curve. You try to be as smooth as you can. So we go like that, connect this one to this, then connect this one to this one here, connect this to that, and then you can extend this one down here to 0. So I can extend it just down there like that. Okay. Now part B, they are saying use your graph to estimate the 30th percentile of the heights of the sunflowers. A percentile is that number that divides the given distribution into 100 equal parts. So P30, we usually represent it with a P something, Pn. So P30 is going to be 30%. So you get 30% times the summation of F, which is given as 150. Okay. And then this one will give us 45. So the 45th value. Then we go to our graph and we look for 45. So 45 is in the middle of 40 and 50. Okay. Then we extrapolate then downwards here. Then what we get, I can even make this one dotted such that it doesn't interfere with the graph that we had. So when they are saying use your graph, this is what they mean. Extrapolate and then get the answer. Now, check this one here. We have, this is 29.5. So this will be now 30.5, 31.5, 32.5, 33.5, 34.5, 35.5. Now, a half of that, we have 35.5. So plus a half of a small box here is equivalent to 1. Okay? So we are adding a 0.5. So a small box is equivalent to 1. So we shall add a 0.5 because it is a half of a small box here. And then our answer becomes 36. So based on mine here, I have 36. You also write yours. They always give a range for the values that you're supposed to get here. Since we all don't draw the same, curve. Okay, so mine is 36 centimeters here. Okay. Part C, calculate estimates for the mean and standard deviation of the heights of the 150 sunflower plants. Now, what we are given here, we don't have the individual data points. So that means we are supposed to get the mid values. Okay. I'm going to draw a table to summarize each and everything that we are supposed to use in finding mean and standard deviation. So I will need the x. I will need f, because when we are finding mean, it is f times x. Okay, that means I will need that column for f times x. Okay, then for standard deviation, I will need fx squared. That means after getting the fx, then I multiply it with the x. Okay, so we are having our intervals 10 to 19. We have 20 to 29. We have 30 to 39. We have 40 to 44. We have 45 to 49. We have 50 to 54. And then we have 55 to 59. Then I can put everything here in the table. So just like that. Okay, now let's find the x, the mid value. So 10 plus 19 divided by 2, this one will give us 14.5. This one is 24.5. This one will be 34.5. This one will be 42, because 84 divided by 2, that is 42. And then 47 here. Then we shall get 52 here. And then here we shall get 57. Okay. Then the frequencies. So when we check back here, we have the frequencies 10, 18, 32, 42, 28, 14, and 6. So I have 10 here, then 18, 32, I'll have 42, I have 28, I have 14, and I have 6. Then we multiply these ones. This one is going to give us 145, okay? Now let's multiply all of them. 24.5 times 18, that is 441. 441. 34.5 times 32, 1104. 1104. 42 times 42, 1764. 1764. 47 times 28, 1316. 1316. 52 times 14, 728. 728. 57 times 6, 342. Then when we sum up all of this, what do we get? Summation of fx. What does it give us? Because we shall need it in the calculation of mean. 145 plus 441 plus 1104 plus 1764 plus 1316 plus 728 plus 342. This one gives us 5840. 5840. Then we come to these ones here. Okay. So we are supposed to get our x here. We square it, then times this f. Or we can get x here, then times the fx. It is all the same thing. So the first one, I can say 14.5 squared, then times the 10. Okay. That one will give us 2102.5. 2102.5. Next, 24.5 squared times 18. 10804.5. 10804.5. Next, 34.5 squared times 32. 380, then 88. 380, then 88. Next, 42 squared times 42. Of course, that is 42 cubed. 42 cubed. 740, then 88. 740, 88. Next, 47 squared times 28. That is 61852. 61852. 52 squared times 14. 37856. 37856. 57 squared times 6. 19494, 19494. Then when we sum up all of these ones here, what do we get? Summation of fx squared is equal to 2102.5 plus 10804.5 plus 38088 plus 74088 plus 61852 plus 37856 plus 19494. So we get 244285. 244285. Now, after this table, I can now find mean. Mean is equal to summation of fx out of summation of f. So here we can have 5,840. Of course, summation of f is 150. So what do we get? 5840 divided by 150. So it is a recurring decimal, but I can write to three significant figures as 38.9. 38.9. I can even put on a 3. The 3 is recurring. Then I put on that dot. Then next, standard deviation. Standard deviation is root of variance. And what is variance? Is summation of fx squared out of summation of f, then minus summation of fx out of summation of f. In other words, mean squared. So here we have the square root of, we have 244285. Summation of f is 150. We subtract this 5840 out of 150, then squared. So when we put everything in the calculator, what do we get? Square root, we have 244285 out of 150. Then next, we are having minus, this is 5840. You don't put the other rounded figure, okay? You just put the whole of it again so that you produce perfect answers. Then you put that squared, then press equals. So to three significant figures, I'm going to write 10.6. This will be 10.6. Three significant figures. Number 5, a factory produces chocolates. 30% of the chocolates are wrapped in gold foil, 25% are wrapped in red foil, and the remainder unwrapped. Okay, Indigo chooses 8 chocolates at random. N is known. Okay, that means this is a binomial. And then they're saying find a probability that she obtains no more than 2 chocolates that are wrapped in red foil. So not more than, this one here means less than or equal. Okay, so probability of x here less than or equal to 2. This one can be equal to probability of x, which is equal to 0. Then we have x is equal to 1. Then we also have x is equal to 2, just like that. Then here we shall have, of course, when we substitute into the binomial, first of all, our p here is 0.25. Okay, our interest is in getting something wrapped in the red foil, and it was given as 25%, which is 0.25. That means Q, anything that is not wrapped in the red foil, is going to be 0.75. Now we shall have here 8 combination 0, and then our P, which is 0.25, and then we put power 0, then 0.75, then power, this will be 8. Remember, when you add these powers, they give you the n, okay, which n is what? 8. Then plus, we shall have 8 combination 1, and then 0.25, then power 1, and then 0.75 to the power of 7. Then lastly, 8 combination 2, and then 0.25 to the power of 2, then 0.75 to the power of 6. Now, we can put everything here in the calculator, and then we simplify everything at once. So which answer do we get? So of course, 8 combination 0, that is 1, and then 0.25 power 0, that is also 1. So I'll just put 0.75, then power 8. Then next, 8 combination 1 is 8. Okay, 8. Then times 0.25, then times 0.75 power 7. Then after that, plus, then we have 8 combination 2, then times 0.25 squared, then times 0.75 power 6. Okay, then I can close the brackets here, and then everything here, when I add, I'll get my answer as 0.679 to 3 significant figures. 0.679 to 3 significant figures. As simple as that. Jake chooses chocolates one at a time at random from the production line. Find the probability that the first time he obtains a chocolate that is wrapped in the red foil is before the 7th choice. Now this one becomes a geometric distribution because the n, the number of times the experiment is done, is not known. Not infinite, but is not known. Okay, so this is a geometric. This is a geometric distribution since n isn't fixed. Okay, now they are saying for the first time on the find the probability that the first time he obtains a chocolate that is wrapped in the red foil is before the 7th. So that is less than. Okay, that is less than. So we are supposed to have probability of x which is less than 7. Let me draw a probability tree diagram here to simplify the work. So you can do the experiment, you obtain a success, and then you fail. When you fail, you proceed. Success, you fail. Now I'm going to go up to the 7th one, below the 7th, so I will end on the 6th. P, then Q, then P here, then Q, then this one is the 5th one, and then the 6th one here. So below 7, it has to be, you consider P, then QP, Q squared P, Q cubed P, Q power 4P, then Q power 5P, all of those ones there. But you realize that it is only this one that I haven't considered. Okay, so why don't I just say 1 minus this one here, Q power 6, and then I go. So I will have 1 minus Q power 6. As simple as that. So we shall have 1 minus, our Q is 0.75, then to the power of 6. Now when we put in the calculator, what do we get to 3 significant figures? 1 minus 0.75 to the power of 6. So what do we get? We get 0.822. 0.822 to 3 significant figures. As simple as that. Okay, if I chooses chocolates one at a time at random from the production line. Then part C, find the probability that the second chocolate chosen is the first one wrapped in the gold foil, given that the 5th chocolate chosen is the first unwrapped chocolate. This was one number that actually gave students hard time, but this is how you can approach it. We have probability. I'm going to write second is the first gold. The second one is the first gold. Okay, given that the 5th one is the first unwrapped. That is the probability they want us to find. Okay, they are saying the second chocolate chosen is the first one wrapped in gold. So I said first gold. Okay, then given that the 5th chocolate chosen is the first unwrapped. So the sample space is the sample space we are choosing from is when the 5th one is the first unwrapped. You see that? So this is conditional probability. That means I will have probability of second gold. Okay, and then second is the first gold picked. Okay, intersection, then the 5th is the first. Okay, is first, unwrapped. The first unwrapped. You see that? Just like you can have probability of A given B, which is the same as probability of A intersection B, then divide by probability of B. So then I will divide by probability of fifth being the first unwrapped. Okay, being the first unwrapped. Now, probability of the fifth being the first unwrapped. How can I get this one here? That means the first four are wrapped. I'm doing 5, 1, 2, 3, 4, 5. But the fifth one, that is where I get the unwrapped. So that means these ones are all wrapped. You see that? So it is the same as saying probability of x is equal to 5. You see that? So you first fail these times here, q, then power 4, then times your success is here. You see that? So I'm going to write q power 4, then p, that. And then for the one that is unwrapped, let's check back. The one that is unwrapped, they gave us the probability. They said that, and the remainder is unwrapped. So let's look at what is unwrapped. This one is 30%, then 25%. That will be 55%. That means this one will be 45%. So our P here is the 0.45 for the unwrapped. You get that? Okay, so getting back here, I'll have the Q is getting the ones which are wrapped. We had the 30% and the 25%. I mean, the 30% and the 25%, which is 0.55. And then the 45% is the one for the unwrapped, which is 0.45. You see that? Now let's go to the next one. How about the probability that the second is, okay, the second is gold, is the first gold, okay, and the fifth is the first unwrapped, the first unwrapped here. Now we check what we are going to have. Let's say we are having 1, 2, 3, 4, 5. If gold is the second one is the first gold, so I can put gold here. Okay, then the fifth is the first unwrapped. You see that? Automatically the first one here has to be the one wrapped in red. Okay, so red here is the one that we are having. Now in between here, it doesn't matter whether we have red or gold. So I can put here there is red or gold. Even here there is red or gold. You see that? Now, what is the probability of getting red? It was given as 25%, so that is 0.25. You see that? Then times, now the green, I mean the gold, is 30%, which is 0.3. Now, red or gold, when we add them together, we get the 55%, which is 0.55. And also here, 0.55. Then the next one, unwrapped. So that one is going to be the 0.45. 0.45. You see that? Now that means our probability now, the required probability, is going to be equal to what we have gotten here, the 0.25 times 0.3 times 0.55. Let me just put a square here, and then 0.45. Then out of what we got here as 0.55 power 4, then times 0.45. Now we put in the calculator and then we get the final answer. So I have 0.25 times 0.3 times 0.55 squared, then times 0.45. Okay, then down here we are having 0.55 power 4 and then times 0.45. So that is 30 out of 121. I can just write the answer as 30 out of 121 as a fraction. okay? Or I can write it as a decimal, whichever. So that is that. Question 6 is coming from combinatorics, that is permutations and combinations. Part A, find the number of different arrangements of the 9 letters in the word happiness. So first of all, they are 9. So I'll have 9 factorial, but then I have repeating letters. I have 2 P's here. So I'll put 2 factorial here, okay? And then I also have 2 repeating S's. So that one will also be 2 factorial. So that means when I put this one in the calculator, what do I get altogether? 9 factorial, then divide by 2 factorial is 2. So I will just divide this one by 4. So 90720. 90720. This becomes our answer. And then part B, find the number of different arrangements of the 9 letters in the word happiness in which the first and last letters are not the same as each other. Now, I can actually consider when the first and last are the same, okay? And then after, I will subtract. So I can have first here and last, okay, are the same. So I can have, these are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can have P's here, okay? These P's. Then I will kill this position here. You see, that means here I'm left with 7 letters. So that means arranging them here, it will be 7 factorial. Then we divide by 2 factorial because we are having 2 S's here involved, okay? Then I can also have another scenario where S's are the ones that are at both ends, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can have S here and then S here. Same to P. Here I will have 7 factorial out of 2 factorial. Now that means inside here we have the 2 repeating P's. They are the ones that will be in here. Now that means that our number of different arrangements, when we have the first, okay, when we have the first and last, okay, different from each other, I will just get the total, okay, without any restriction, which we got as 9 factorial out of 2 factorial times 2 factorial in part A. And then we subtract these 2 scenarios that we have gotten here. So I'll just say 2 then times 7 factorial over 2 factorial, right? Because there are 2 of them. So now when I put this one in the calculator, what do I get as my final answer? 9 factorial. Remember, it is over 4, then minus. I'll have 2 times, then 7 factorial, divide by 2 factorial. So altogether, this one gives me 85680. 85680 as the final answer. Part C, find the number of different arrangements of the 9 letters in the word happiness in which the 2 P's are together and there are exactly 2 letters between the 2 S's. Okay. This one was also one of the parts that disturbed students. So we are going to consider 2 scenarios here. Scenario number 1, first of all, let us draw this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first scenario is when I have these 2 P's outside of the S's. So since there are 2 letters that are in between the 2 S's, the 2 P's can also be in between the 2 S's. So I can write S here and then this one here. No. It will be here so that I have 2 letters in here. You see? Now, this simply implies that we are going to have this as one group. This is the second group. Then now 3, then 4, then 5. Okay, so I'm taking that. I take this as 1 letter, then 1 letter, then 1 that I'm going to put here, and then there. Okay, now how we can arrange these ones, it can be 5. Let me just write it down here. This one is going to be 5 factorial. Okay, that is how we can arrange, like the way those ones are. Then next, we have letters that we are going to put here. Out of the 5 which are remaining, I'm going to choose 3 and then I put them there. So when I choose those 3, I'm going to have 5 combination 3. You see that? Then next, of course, the ones that will go here, I can say there are 2 that are remaining, so 2 combination 2. Do you see that? Then after that, these letters that I'm putting here, since they are different, okay? Since they are different, then we can arrange them in 2 factorial ways. One can be here, another one here. Then again, they switch. You see that? So I can multiply this with the 2 factorial. So simplifying this, what do we get? 5 factorial times 5 combination 3 times 2 combination 2 is of course 1, and then 2 factorial is 2. So that is 2,400. 2,400. Then the second scenario, 1, 2, 3, 4, 5, 6, 7, 8, 9, is when we have these P's in between the S's. Okay? So this one, I'm going to take it as one group. It has to be like that. So it can move here, 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 here. Okay? So we are going to have that group there. So this is one group. Now 1, 2, 3, 4, 5, 6. Okay? So I'll write this one as 6 factorial. So this one will give me 6 factorial. Well, these ones here are all different. Okay? So that is that. I would have put times 2 factorial because these 2 P's can be written in 2 factorial ways, but they are identical. So that means I will also divide by 2 factorial. The same for S's. I will do that, but then also divide because I'm arranging them in a line and yet they are identical. So we don't therefore add on that. Now, we just now put down the total. So the total is now going to be that 2400, then plus the 6 factorial. And I think 6 factorial is 720. So what do we have altogether? 2400 plus 6 factorial. This one gives us 3120. 3120. As simple as that. Next, the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. Part D, find the probability that both P's are in one group and both S's are in the other group. So this is what I'm going to consider. Number 1, the 2 P's, okay, in a group of 5. In a group of 5. So we have 1, 2, 3, 4, 5. I have those 2 P's, okay. Then I put off the S's when I'm choosing letters to go here, okay? The S's have to be out. So that means I'm choosing from 5. What are the 5s that I'm having? I have the H, I have the A, I have the I, the N, and the E. So out of those 5, I need only 2. I mean 3. So here I'll have 5 combination 3. You see that? Then if the 2 P's are in a group of 5, that means the 2 S's are in a group of 4. You see that? 1, 2, 3, 4. I have the 2 S's there. So meaning after choosing the 3 and I put them here, then the 2 that are remaining, I'll put them here. So 2 combination 2. You see that? Then there is another scenario. I can have the 2 P's in a group of 4. In a group of 4. And then the 2 S's in a group of 5. Now this is 1, 2, 3, 4. Then 1, 2, 3, 4, 5. So I can have the 2 P's here. That means out of the 5, I'll only pick 2. So this will be 5, then combination 2. And then the 2 S's are here. Then the remaining 3, then I'll put them here. That means the probability is going to be equal to, the first one is 5 combination 3, then times 2 combination 2. By the way, it doesn't matter whether you first pick and put here or you first pick and put here. If I first pick and put here, that means I'm going to have 5 combination 2, okay? Then 3 combination 3. 5 combination 2 is the same as 5 combination 3. Try it on your calculator and see. It is the same. So then this is for the first one. The second one, I'll have 5 combination 2, then times 3 combination 3. Then I'll divide by the total sample space without any restriction. In the group of 5, remember you're having 9 letters. So 9, just choose the 5 and put in that group. Then the remaining 4, put them in the other group. Or you can begin by choosing the 4th. Okay, out of the 9, then you choose 4, then times the remaining 5, put them in the other group. 9 combination 4 is the same as 9 combination 5. Also check that out on your calculator and you see. Okay, so I'm going to put all of this together. 5 combination 3 is a 10. This is 10, and then this is of course 1. Then the next one, 5 combination 2 is also 10, because it is the same as that for 5 combination 3. 3 combination 3, that is also 1. And then here, 9 combination 5, what do we get? Of course, this one is 1, okay? So I have 9 combination 5, then times the 1 there. So let me put everything on the calculator, then we get the final answer. 10 plus 10, that is 20. Then we divide by 9, then combination 5. That is 10 out of 63. So I will write this as 10 out of 63. I can leave it as a fraction. Where you are asked probabilities, it's better you leave them as fractions. Okay? It looks better that way. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.